Hello students. In this video, we're going to find how to differentiate certain functions using chain rule. So let us start the lesson. So let us consider y equals f of x. Okay. Now dy by dx. We all know that it means the derivative of y with respect to x. Okay. Let me ask you a question. Does dy by dx mean dy divided by dx? For example, we say 3 by 4 is nothing but 3 divided by 4. Okay, can you do this? Can you say the same thing? Dy by dx means dy divided by dx? No, we cannot. It is wrong. Okay, this is wrong. This is correct. So basically, dy by dx is not a fraction. It's not like numerator is dy and denominator is dx. That is incorrect. Dy by dx is basically like a name given to a derivative. It's like a mathematical notation, okay, like a symbol, okay. So it is not a fraction. So this is one thing that you need to keep in mind. Okay, one more thing you need to remember is dy by dx can be written as dy by du multiplied with du by dx. Okay, now does it look similar to this, students? Like for example, 3 divided by 4 is nothing but 3 by 4 multiplied, let's say 3 by 5 multiplied by 5 by 4, isn't it? Like for example, I cancel 5 and 5 here, so it becomes 3 by 4. So can I say similarly dy by du into du by dx, where u is a function of x, I cancel du and du, then I get dy by dx, isn't it? That is not correct. So this is correct, again this is wrong. Okay, so again we cannot cancel du and du. As I mentioned earlier, they are not numbers. Okay, I mean dy by du is not a fraction, it is a name, so you cannot cancel like that. But still this is true. This dy by dx equal to dy by du into du by dx, that is correct, but we cannot just cancel du and du. Okay, so you have to keep this in mind as well. Okay, so let us see once more. What I said right now is dy by dx can be written as dy by du multiplied with du by dx. So this is correct. Okay, same way I can write dy by dx as dy by, let's say, dv into dv by dx, not a problem. So you can write u, or you can have v, or you can have a, b, c, d, anything you can. I mean not d, of course we are already using d. You can have any other letter in the English alphabet. Okay, fine. Now let us look at a problem. Y equals sine of x squared plus 3. Now let us see how to find the derivative of this function using chain rule. What I'll do is I'll take this x squared plus 3. I'll take this x squared plus 3 as some u. Let u be. So as you can see, u is a function of x. Then y will become sine u, isn't it, students? Okay. So as I mentioned earlier, my objective is to find dy by dx. So dy by dx equals dy by du multiplied with du by dx. That's fine. Now, how do I find dy by du? Now you can see here y equal to sine u. So dy by du is nothing but cos u, isn't it? Derivative of sine is cos. So I get cos u here. Okay. Now next I need to find du by dx. Again I have u equal to x squared plus 3, which implies du by dx equals 2x, isn't it, students? So I get 2x. So finally I'll write cos, instead of this u, I write x squared plus 3 into 2x. So the final answer is 2x cos of x squared plus 3. So this is the derivative of the given function. So I hope it is clear. Let me explain it with another example. Okay, now let us take this example. Y equals square root of x cube plus 2. Okay, I want to find the derivative of this function. That means I need to find dy by dx. What I'll do is I'll take I'll take this x cube plus 2 as u. Then what I get, y equals root u, isn't it? So dy by dx equals dy by du multiplied with du by dx. Okay, again, how do I find this dy by du? Very simple. You have y equal to root u. So dy by du is, we know that the derivative of root x is 1 by 2 root x. So 1 by 2 times root u. So that is the answer, 1 by 2 root u. Okay, now again, I need to find du by dx. Again, I use this line, I use this function. So du by dx equals 3x squared. That is the derivative. So I get 3x squared. So the final answer is 1 by 2 times root of u is nothing but x cubed plus 2 multiplied with 3x squared. Okay, so this is the derivative of the given function. So we use the chain rule to find the derivative. Okay, so I hope it is clear now. What I'll do is I'm going to give you a problem. I would like you all to pause the video, solve the problem on your own, and then later play the video again. Okay. Okay, so this is your problem. Y equals cos of, let's say, x cube plus x squared plus 1. Okay, students, this is your problem. Now please find dy by dx. I'll just give you a hint. You need to take this x cube plus x squared plus 1 as u. Okay, start solving it. Fine, let us see whether you're right or wrong. So y will become cos u dy by dx is nothing but dy by du multiplied with du by dx. So it means dy by du, again dy by du is nothing but minus sine u. So I get minus sine u multiplied with, I need to find du by dx now, so I'll use this. So du by dx equals 3x squared plus 2x plus 0. Okay, so I get 3x squared plus 2x in brackets. So the final answer is minus sine of x cubed plus x squared plus 1 multiplied with 3x squared plus 2x. So this is the derivative of the given function. So I hope you got this same answer. Okay, let us see how to find the derivative of this function using chain rule. I'll take this x cubed minus 5 as u, then y will become log u to the base e. So now dy by dx equal to dy by du multiplied with du by dx equals, now dy by du is nothing but, from here I'll get it from here. So dy by du, we know that derivative of log x to the base e is 1 by x, so it is 1 by u. So I get 1 by u multiplied with, now I need to find du by dx. Again use this. So I get du by dx equals 3x squared. Okay, so I get into 3x squared. So the final answer is 1 upon x cubed minus 5 multiplied with 3x squared. Sorry. So this is the derivative of the given function. So this is how we do, we find the, we differentiate certain functions using chain rule. Now, by now you'll all agree, students, that this is quite lengthy, isn't it? By writing u and then du by dx and then y equal to y in terms of u and then using this dy by du multiplied with du by dx, it takes a lot of time, isn't it? Now there is an easier way to find the derivatives of the function using chain rule without actually using all these steps. Okay, so that is what we are going to learn right now. So let us see. Now we saw that the derivative of sine of x squared plus 3 is nothing but cos of x squared plus 3 multiplied with 2x, isn't it? Okay, now we also saw that let's say sine of 3x. When you actually use the sine rule, you will get cos of 3x multiplied with 3. Now, do you see any pattern, students? Now, let us please look at it carefully. Okay, now sine, cos. So, derivative of sine of x square plus 3 is cos of x square plus 3. Now, and the derivative of this x square plus 3 is 2x, isn't it? Yeah, same way, look at it please. Derivative of sine of 3x is cos of 3x. I multiply that cos of 3x with the derivative of 3x, which is 3. Okay, I hope you understood what I'm trying to say. So let us say sine of 3x power 4. So can you please tell me what will be the derivative, students? Okay, these are the derivatives. So what will be the derivative, students? It's very simple. Cos of 3x power 4 multiplied with derivative of 3x power 4, which is 12x cube. Okay, let us say sine of, let's say, x by 3. Then what will be the derivative? Very simple. I have sine here, so that means cos of x by 3 multiplied with, I find the derivative of x by 3, which is nothing but 1 by 3. Okay, one more example. Sine of 5 minus 3x. So what will be the derivative? Very simple. Sine of 5 minus 3x, so derivative of sine is cos, so it will be cos of 5 minus 3x multiplied by derivative of 5 minus 3x, which is nothing but minus 3. Okay, so I hope you can see the pattern right now, how it's very simple. So what I'll do is, I'm going to give some functions and I would like you to answer them. Okay, let me write f of x here and f dash of x. Okay, as you can see here, I have given 5 functions. I would like you to find the derivative of each one of them using the shortcut method that I taught you just now. Okay, so start doing it now and you can pause the video and complete all the problems. Okay, fine. The answers are, derivative of cos is minus sine, so it is minus sine of x squared plus 2 multiplied with 2x, which is the derivative of x squared plus 2. Now in this case the answer is minus sine of 5x multiplied with 5, because 5 is the derivative of 5x. Now here it will be minus sine of e power x multiplied with derivative of this is e power x. Now again here it will be minus sine of sine x multiplied with derivative of sine x is cos x. Finally I'll get minus sine of log x to the base e multiplied with derivative of log x to the base e is 1 by x. So these are the correct answers. So I hope you got all of them correct. Okay, so let me give you some more problems. Okay students, so please find the derivative of these 4 functions using the chain rule, and the clue is, we know that the derivative of tan x is nothing but 1 over cos squared x. So that is a clue. So please start doing it now. Okay, so let us see the answer. It is 1 by cos squared 3x multiplied. So this I get because of tan, multiplied, then 3x, so the derivative is 3. Okay, so second one, 1 by cos of x squared plus x multiplied with derivative of this, which is nothing but 2x plus 1 is the answer. The third one, tan of root x, so 1 by, I'm sorry, this is cos squared. Okay, it 1 by cos squared root x multiplied with derivative of this is 1 upon 2 root x, right? And finally, for this one, the answer is 1 by cos squared of 4 minus x multiplied with derivative of 4 minus x is minus 1. Okay, so these are the correct answers. Now I've seen many students make this mistake. Now for example, you get sine x multiplied with x. So what they write is, they write, okay, x into x is x squared, so you write sine x squared, which is wrong. Okay, you cannot write like that. Then how do I write it? If it is sine x into x, you write it as x sine x, that's all. You cannot multiply this x with this x. It's not possible because this is actually a function. Sine x is a function, and it is not like something like sine into x. Okay, so that is incorrect. So please keep this in mind. Now we saw trigonometric functions and the combination of trigonometric and exponential, trigonometric and logarithmic, trigonometric and algebraic functions, trigonometric and trigonometric functions. So let us see now exponential functions. Okay, particularly e power and functions involving e. Let's say, let me write f of x here and f dash of x. Okay, now if the function is e power x squared plus 2, the derivative will be e power x squared plus 2 multiplied with 2x. Suppose if the function is e power sine x, then derivative will be e power sine x multiplied with cos x. Okay, again, do you see a pattern, students? We know that derivative of e power x is e power x, isn't it? So derivative of this, same thing repeats again, but only thing is this I got by differentiating this x square plus 2. Okay, same way e power sine x, I got e power sine x, like derivative of e power x is e power x, but this I got this cos x by differentiating the sine x. Okay, I hope you got the pattern. Now let me give you some more problems. So e power, let's say 4x. So what do you think the derivative will be, students? Okay, let's say e power minus x. So what will be the derivative? So e power 1 minus 3x. So please write the derivative. Okay, pause the video and write the answers. Okay, now the answers are, for this one it is e power 4x multiplied by 4. Now for this one it is e power minus x multiplied with minus 1. Okay, now again e power 1 minus 3x is same, so e power 1 minus 3x multiplied with derivative of 1 minus 3x, which is minus 3. Okay, so isn't it simple, students? It's very, very simple. Let us see okay, some problems involving logarithms now. Okay, maybe let me give you some more problems in exponential so that you are quite thorough. So f of x and f dash of x. Okay, fine. So please find the derivatives of this given function, students. Pause the video now and please do it. Okay, let us see the answers. So the answer is e power x plus sine x multiplied with derivative of this, which is nothing but 1 plus cos x. Okay, in this case the derivative is e power 4 plus 3x squared multiplied with derivative of this, which is nothing but 0 plus 6x. Okay, in this case the derivative is e power minus 2x multiplied with minus 2, because minus 2 is the derivative of minus 2x. Okay, now finally this one is e power root x multiplied with derivative of root x is 1 over 2 root x. Right, so these are the correct answers. So I hope you got all of them right. Okay, so we saw trigonometric functions, we saw exponential functions. Let us see logarithmic functions now. Okay, let us look at these functions. I have given 5 logarithmic functions. First one is log of x squared plus 3 to the base e. All of them are natural logarithms. Second one is log of sine x. Third one is log of x cubed plus x squared. Fourth one is log of 4x. And fifth one is log of 1 minus 2x. Okay, now we all know that derivative of log x to the base e is nothing but 1 by x, isn't it? So if you use the chain rule, like taking u as x squared plus 3 as u and everything, I will get this answer. I will get 1 by x squared plus 3 multiplied with 2x. Okay, so can you see a pattern, students? Log of x squared plus 3, so 1 over x squared plus 3, like 1 by x. And then 2x, I got it by differentiating x squared plus 3. Same way, for the second problem, I will get 1 over sine x multiplied with derivative of sine x, which is cos x. So I'll basically get cos x by sine x. So I hope you got the hang of it. Now please solve the third, fourth and fifth problem on your own. Please pause the video now. Okay. Now the answer is 1 over, for the third one, x cubed plus x squared multiplied with 3x squared plus 2x. Of course, you can take x common in the numerator and denominator and then simplify this expression. I'll leave that to you. Now for the fourth problem, the derivative is 1 by 4x multiplied with 4, which is nothing but 1 by x. Okay, the last one is the derivative is 1 over 1 minus 2x multiplied with minus 2, because minus 2 is the derivative of 1 minus 2x. So I hope you understood how to find the derivatives using chain rule if it involves logarithm. Very simple. Okay, now let us look at these functions, 5 functions involving square root. We know that derivative of root x is 1 by 2 root x. So derivative of the first function is nothing but 1 by 2 root of x squared plus 5 multiplied with 2x. Okay, now how did I get this? Very simple. This root gives me this 1 by 2 root this, and this 2x I got it from this x squared plus 5. Okay, very simple. So let us find the derivative of the second function. Root is involved, so derivative of root x is 1 by 2 root x, so 1 by 2 root of sine x multiplied with derivative of sine x, which is cos x. So this is the answer. Let us see the answer for the third one. 1 by 2 root of 4 minus 3x multiplied with derivative of this, which is nothing but minus 3. Okay, the fourth problem, 1 by 2 root of e power x multiplied with e power x. Okay, here in fact you can cancel 2 and 2. And finally, for the last problem, the derivative is 1 by 2 times square root of x plus cos x multiplied with derivative of this, which is nothing but 1 minus sine x. Okay, so these are problems involving square root functions. Now finally, we are going to see problems involving algebraic function. For example, let's say x cubed, x squared, like that. Okay, that's what we're going to see. Okay, let us find the derivative of these functions now. You can see 5 functions given here. Now let's look at the first function. Doesn't it look like, let's say, x power 4, students? We know that the derivative of x power 4 is 4x cubed. So derivative of this function is nothing but 4 times x cubed plus x squared power 3 multiplied with 3x squared plus 2x. So I hope you got how you got the first one. So this expression we got because this looked like x power 4. Okay, now this one we got by differentiating what is inside the bracket. Okay, so let us look at the derivative of the second one. This is nothing but 10 times 2x plus 3 raised to 9. It's like, looks like 10 power x power 10 multiplied with derivative of 2x plus 3, which is 2. Okay, so this is the answer. For the third one, the answer is 3 times 1 minus 3x raised to 2 multiplied with derivative of this, which is minus 3. So I'll get minus 9 times 1 minus 3x the whole square. Okay, let us look at this from sine cube x. I can write sine cube x as sine x the whole cube. Now this again looks like x cube, so the derivative is 3 times sine x the whole square multiplied with derivative of sine x is cos x. So for the finally, this one can be written as 5x plus 1 raised to minus 3. So the derivative will be minus 3 times 5x plus 1 power minus 4 multiplied with derivative of 5x plus 1, which is 5. Okay, so I hope it's clear now. So what I shall do is I'm going to give you 10 problems, a mixture of 10 problems. I would like you to solve it on your own and then cross check whether what you've done is right or wrong. Okay, these are the 5 sums, students. Please find the derivative of all these functions. Pause the video and start doing the problems, solving the problems. Okay, now the answer for the first one is nothing but minus sine 3x multiplied with 3. The answer for the second one is e raised to tan x multiplied with 1 by cos squared x. And for the third one, the answer is 1 by 2 root of 5x plus 2 multiplied with 5. For the fourth one, it's nothing but cos x the whole square, so 2 cos x multiplied with minus sin x. And finally, the last one, the derivative is 1 by x cube minus 1 multiplied with 3x squared. Okay, so these are the correct answers. Okay, students, let us start solving some problems now. Let's say y equals e power minus 1 by 3x minus log of 2x to the base e plus 9x squared. So dy by dx will be, first I need to differentiate this. We need to use a chain rule. So derivative of e power x is same. So e power minus 1 by 3x multiplied with derivative of this, which is minus 1 by 3 minus. Now next I need to find the derivative of this. I know that derivative of log is 1 by x, so 1 by 2x multiplied with derivative of this 2x, which is nothing but 2 plus, now this is straightforward, which is nothing but 9 times 2x. So the final answer is minus 1 by 3 e power minus 1 by 3x minus 1 by x plus 18x. So this is the derivative of the given function. So I hope it is clear. Good. Let us see another problem. Okay, so this is the next problem. Y equal to sine of x squared plus sine squared x. I can write this as sine of x squared plus sine x the whole square. Okay, so let me find dy by dx. Now for the first one, for sine it is cos, so cos of x squared multiplied with derivative of x squared, which is 2x plus, now this looks like x square, isn't it? Like it looks like x square. So the derivative of x square is 2x. So I get 2 sin x multiplied with derivative of sin x, which is cos x. So this is the answer. Let us see one more problem. So this is the next problem. Y equals log of x sin x to the base e. Now, okay, let me find the derivative of this. So dy by dx is nothing but, derivative of log is nothing but 1 over x sin x multiplied with, now I need to find the derivative of this, isn't it? Now, to find the derivative of this function, I need to use the the product rule. So the product rule says the first function, which is x, derivative of first function is 1, multiplied with the second function, plus the first function multiplied with derivative of second function, so derivative of sin x is cos x. Okay, so this is the derivative of the given function. Okay, so the last, okay, one more problem. I'll take y equals log of cos squared x plus 1 to the base e. So dy by dx is nothing but 1 by cos squared x plus 1, isn't it? Because for if it is log of anything, then 1 by that thing, multiplied with derivative of this, which is nothing but derivative of cos squared x is 2 cos x into minus sin x plus 0. So this is the answer. This is the derivative of the given problem. Okay, fine students. Now I'm going to solve around 5 to 6 problems, and with that we shall wind up this session. So the first function is this, first problem is this. So dy by dx, as you can see, we have to use the product rule. So this is the first function, and this is the second function, right? Okay, so the product rule says derivative of first function, which is 1, multiplied with, I'll keep the second function as it is, which is log of x cubed plus 2 to the base e, plus, now I'll keep the first function as it is, which is x multiplied with, now I will differentiate the second function. So it is nothing but, now I have to use the chain rule. Logarithm is there, so derivative of log x is 1 by x, so derivative of this is 1 over x cubed plus 2 multiplied with, now you have to differentiate this x cubed plus 2, which is nothing but 3x squared. Okay, of course you can simplify further. You multiply this 3x squared and x, it will become 3x cubed. Okay, so this is the answer for this problem. Let us see one more problem. Let's say y equals cos of x log x to the base e. Okay, now what is dy by dx? This is the second problem. So dy by dx is, first I'll do it for the cos. Derivative of cos is minus sign, so minus sign of x log x to the base e multiplied with, now I need to differentiate this. Done. Now to differentiate this, I need to use the quotient rule, so I'll put a bracket here. So first function, derivative of first function is 1 multiplied, I'll keep the second function as it is, log x to the base e, plus keep the first function and differentiate the second function, which is log x, so derivative is 1 by x. So you can cancel x and x. So this is the final answer. Okay, now one more problem. Let's say let me take y equals x squared log of sine 4x, sorry, it's not very clear, sine 4x to the base e. Again, I need to use the product rule and the chain rule. So dy by dx is differentiate the first function, which is 2x, multiplied, keep the second function as it is, so log of sine of 4x, sine of 4x to the base e, plus, now I'll keep the first function as it is, which is x squared, multiplied with, I will differentiate the second function now. Now again, I need to use the chain rule. Logarithm is there, so 1 by sine 4x multiplied. Next, you do it for sine, which is nothing but cos 4x multiplied with, next finally you do it for 4x, which is 4. Okay, so this is the derivative of the given function. One more sum. Let me take y equal to x multiplied with x squared plus 2. Okay, so let me find the derivative of this function. So dy by dx is nothing but, use the product rule, differentiate the first function, derivative of x is 1, multiply, keep the second function as it is, square root of x squared plus 2, plus keep the first function x multiplied with, now I need to differentiate this. Now it is square root of x squared plus 2. We know that square root of x, the derivative is 1 by 2 root x, so it is 1 by 2 root of x squared plus 2 multiplied with, I need to differentiate x squared plus 2, which is 2x. So cancel 2 and 2, and then multiply this x squared and x, you will get, you need to simplify that further, right? Now let us look at this problem where we need to use the chain rule as well as the quotient rule. So dy by dx is the denominator, which is root of x plus 1, multiplied with derivative of the numerator. The numerator is 1, so sorry, x, so derivative is 1, minus numerator multiplied with derivative of the denominator. Okay, now this is the denominator. Now we know that square root of x, the derivative is 1 by 2 root x, so it is 1 by 2 root of x plus 1 multiplied with derivative of this x plus 1, which is 1, divided by denominator, so root of x plus 1 squared. So this is the answer. Now the denominator will become x plus 1, isn't it? Because when you square it, the square root will vanish. So this is the answer. Now let us do one more. Okay, so this is the problem. Y equal to e power minus root x multiplied with sine root x. So dy by dx equal to, okay. Now first I'll differentiate the first one. Now it looks like e power x, so derivative is the same thing, so e power minus root x multiplied with, now I need to differentiate the power, okay, so which is nothing but minus 1 into derivative of root x is 1 by 2 root x multiplied with the second function, which is sine root x. So only one part is over, plus, now I'll keep the first function, which is e power minus root x as it is. I'll multiply that with the derivative of the second function, which is sine root x. Now sine derivative is cos, so cos root x multiplied with derivative of root x, which is 1 over 2 root x. Okay, so this is the final answer. Okay, the last two problems of this video. Okay, so y equal to e power minus x multiplied with the root of x squared plus 9. So dy by dx, use the product rule, derivative of the first function, that is derivative of this is e power minus x multiplied with minus 1. I hope you know why we got minus 1. We got it from minus x, derivative of minus x multiplied with, I'll keep the second function as it is, square root of x squared plus 9, plus, now I will keep the first function, which is e power minus x, and I'll differentiate the second function, which is square root of x squared plus 9. We know that the derivative of root x is 1 by 2 root x, so 1 by 2 root x squared plus 9 multiplied with derivative of x squared plus 9, which is 2x. So cancel 2 and 2. So this is the final answer. I hope you understood this. Now for the last problem of this video clip, let us take a quite challenging problem. Okay, so y equals square root of cos cubed of x squared plus 1. Okay, I can rewrite it as square root of cos of x squared plus 1 the whole cube. Okay, let me find dy by dx. So dy by dx is, first I will do it for the root, so which is nothing but 1 by 2 root of cos of x squared plus 1 the whole cube multiplied with, next I will do it for this 3. That means like x cube, the derivative of x cube is 3x square, so 3 times cos of x square plus 1 the whole square multiplied with, so root is over, the power is over. Next I will do it for cos. Derivative of cos is minus sign, so minus sine of x squared plus 1 multiplied with, finally I will do it for x squared plus 1, which is 2x. Okay, so this is the derivative of the given function. So I hope you learned chain rule thoroughly, students. Now you please solve more problems which are mentioned in the book to understand this concept better. Okay. Thanks for watching this video. Thank you.